Hey guys. All right, let's talk about domain and range. Okay, so domain and range. Relation, we've already talked about this, is a set of ordered pairs, x and y. Special relation is a function, right? And that is special because for every x value, there is exactly one y value. So now let's talk about the domain and range. When studying functions, it's important to be able to identify the potential input values, which is called your domain, and the potential output values, which is called your range. So let's look at this problem here, and we're going to find the domain, which is your x's, okay? So we always denote domain by a capital D. So remember that our domain is always our x's. So we're going to find our domain. Here's open with a brace, and then we just list our x's, which is pretty simple. It's always the first coordinate. So it would be 2, 3, 4, 5, and 6. Okay. These are, like it said, our inputs. All right. All of that is said down here. I just thought I would say that real quick for you guys. This paragraph down here, I know you guys are capable of reading it, so I'm going to let you do that. I'm just going to kind of hit on some high points so you guys can watch the video as well as read the sheet. So remember, again, like I said, your domain is always denoted by a capital D. That is your domain. Oh, that's supposed to be an O. Can't spell. Well, I'm not an English major. So our domain is our x's. That tells us how wide our function is, or our graph is. And we always write it left to right, like we read a number line, okay? So left to right. Okay, now let's talk about our range. Our range, well, you'd probably guess it, you denote it with a capital R. These are our Y's. This tells us, well, how tall, right? And then we always denote, when we write these, it goes from bottom to top. May not have enough room for that here. There we go. Yeah, we do. Right on. Okay. Domain and range are always written in interval notation, like it says right here. So let's talk about interval notation real quick, okay? Ooh, so tricky writing toward the bottom. Okay, so interval notation. If you have an open circle, or, that's my little tricky comma, strictly a less than or greater than, that this little sign, like a arrow like this, that means implies. So that implies that we're going to use parentheses, okay? Also, another time that we always use parentheses is if we have a negative infinity or a positive infinity, okay? Because you can't attain that, right? It's exclusive. We can't get there. So we always use the parentheses, okay? So now, if we have a filled-in circle, so I'm going to do my best to make that happen, or if we have a less than equal to or a greater than and equal to, that implies that we're going to use brackets. Now, how I remembered this in college algebra, I'm going to tell you all my silly ways that I remembered things. You could like use them to remember things, or if they just simply seem silly to you, then just forget them. But if it's an inequality that has a bar on the bottom, then I use the grouping symbol that had the line here. Let me say that over again. If it was an inequality that had a line at the bottom, then I use the grouping symbol that had the lines on it, right? So that's how I remember. So that's how you know to use the brackets, okay? Just simply any less than or greater than, parentheses. Less than or equal to, or greater than or equal to, then you use the brackets, okay? That's interval notation, kind of in a nutshell, just a quick look at it. So that goes with our domain and range. So here, that's on the next page. I have to clear this to go to the next page, so here goes. Okay, let's look at this graph and let's decide what its domain and range is. Remember that I said to read left to right, okay? So it's always, I'm going to write that down up here so we know. Sorry, that was cursive. Left to right. Always left to right. So our domain, we start over here on the left and we go all across until we see our first point. And it's an open circle, as I said earlier. So we know that that's going to be a parenthesis, right? Domain denoted with a D. Parenthesis, well, that's at -3. Okay. And then we're going to keep on going along here until we get to where it stops. We go down, we see that's a closed circle. So we know that that is going to be a +1. And since it's a closed circle, he gets a bracket. Cool. Now let's do our range. We've already discussed that's from the bottom to the top. So we start at, our range is our y's, we go over here, and that's a -4, but it's a filled in circle, so that's going to be bracket -4. And we go up to, well, the highest point that it is x equals 0, but we see that it's a open circle, so we give it a 0, and then a parenthesis. I make my zeros funny. I don't know where back in my lifetime I started putting a line through them, but I did, so it's a hard habit to break, so expect me not to break it this semester. Remember, this is bottom to top. And our little guy here, well, I already put left to right. I'm ahead of myself, aren't I? Okay, so that's all set down here, just trying to hit the high points. Okay, let's look at this one. It says, I'm going to clear that one and scoot down a little bit so we have some more room. Okay, we're going to find the domain and range for this guy. So the domain is all real numbers, right? Because this is a polynomial. Let's look at him. If I can find my pen. He is a polynomial, right? Because he's got x squared. There is no x, but this guy, since he is just a constant, he's technically x to the 0, because anything raised to the 0 power is 1. So this guy is a poly. I know it's a polynomial, but, you know, we're on close terms, so I could give him a nickname. I'm lazy too. I'm just going to tell you, mathematicians as a whole are lazy. I fit that stereotype, so I will use shorthand or I'll abbreviate whenever possible. So with a polynomial, your domain is always going to be all real numbers. And here's the symbol for all real numbers. Again, lazy. So that's a symbol for all real numbers. If you want to write it, well, we are going to write it, let me say that way, with the D equals all real numbers. To us tells us that it could be any number on the number line from -infinity to +infinity. Okay, that's what all real numbers mean. So we could put any real number in here from -infinity to +infinity, and it'll be a true statement. All right. Did not mean to do that. Okay, so let's look down here. I'm going to clear that real quick, and we're going to go on down, and we're going to look at this next one. Talks about restrictions on the domain. So let me go back up a little bit so I have a little bit of, maybe if it will please go. There we go. When we start making assumptions about functions and their domains, we always, first thing that we do is we assume all real numbers. Ooh, that's an E, hello. So we assume all real numbers, but then we have to look for two restrictions. The first restriction is there an X? Let's go. No, let's go back down. I didn't mean to do that. I apologize. I'm just really impressed that it's the first time I've done it today. Okay, first thing we assume all real numbers, and then we have to look for x's. I'm going to make this bigger again. Not as big as it was, though. Okay, try again. X's in the denominator. Here we go, my abbreviation for Alright, I'm just going to say it. First of all, you look for all real numbers, and then you look for x's in the denominator. So first restriction, and the other one is x's under an even root. Well, those are our two exclusions, okay? So let's look at our problems here. 6 divided by 0, well, we all know that's a 0. 0 divided by 0, yep. 0 divided by 6, well, 0 divided by anything gives us a happy little 0. And then the square root of 4, 2. But here we go. We have a x underneath an even root. No, this is where we get this from, is because we don't want a negative underneath here, right? So since we have a negative underneath here, that's going to throw us into our imaginary world where we seldom like to go. So we have to pull an I out to get this negative out from underneath there. So it's going to be 2i, right? Because that makes us go into the imaginary world. Now the cubed root of 8, that just asks us what number do we have to multiply times itself 3 times to get 8? Well, that would be 2. And then the cubed root of negative 8, well, that would be negative 2, right? It's not an even root, so that's not against the rule to have a negative underneath there. So it asks what's the two trouble spots. Well, it would have been the x. If there would have been an x in the denominator, would have caused a problem here. Oh, here we go. So x in denominator. And the other one is the x under the even root. Wow, there's an O there, sorry. Okay, let's do these real quick and then we'll be done with this, okay? So this first one is going to prove to have an x in the denominator, right? So we got to find out what would make that x be 0. So to do that, we just take x plus 3, set it not equal to 0, okay? Then we solve. So anytime there's an x in the denominator, we take the denominator, set it not equal to 0, and solve. So we're going to subtract 3 from both sides, right? So x cannot be 3. Now, to write that in interval notation, which we need to do, so we will put it on a number line. We assumed all real numbers, right? Because that's what I said. The first thing that we're going to do is assume all real numbers. Now we're looking at our restriction. So let's say it can't be 3. So we're going to have 3 here. But it could be any number here or any number here. Just not 3. Well, we know this goes off to negative infinity. Ooh, that's an infinity. And this one goes off to positive infinity. So we always read left to right, correct? So we're going to say, we start over here at negative infinity. And we can come all the way up as close as we can get to 3, but not 3. So we have to use a parenthesis. Now, we're going to have to jump this guy, right? This side, jump him. To denote a jump in math, we always do a union, okay? Like a horseshoe. And then we're going to put another parenthesis because we're going to pick back up on the other side of 3. And then we're going to go to infinity. Cool? So that would be our answer here. That's not much space to put that answer, but that's how we would do it. All right, I'm going to get rid of all this. Let's do the next one. The next one is we have to set the radicand, which is what lives underneath the square root or the radical. We're going to set it greater than or equal to 0. That's the rule. So we're going to take x plus 7, set it greater than or equal to 0. You ask why greater than or equal to 0? Because we cannot have a negative under here, right? We saw that up here what the negative does. It throws us into imaginary land. Don't want to go there. So again, we're just going to move the 7 over because we're solving for x. Ooh, funky line there. So this is going to be x is greater than or equal to negative 7. So we know since it's greater than or equal to, it's always going to be a bracket, right? So let's put him back on our line again. Now, negative 7. Fun trick. If your x is on the left-hand side and it's an inequality symbol, you can treat the inequality symbol like an arrow. So we know that our x is going to go this way, right? Bam. So it's going to be d equals, if I can make a d, challenging this, writing on this little tablet. So the denominator is going to equal, ooh, undo, epic teacher fail, okay. There we go, negative 7, wow, negative 7 to infinity, there we go. I'm trying to hurry up and get done so y'all can quit watching me and get on with your day, but okay, there you go. Now, that would be your domain here. Undo. This next one, same thing. We don't care what's in front of it at all. We just care about the radicand, okay? This guy, the same thing, right? We're just going to take the denominator. I'm going to do him here. He's bigger. Oh, I'm going to grab a pen first. Maybe. It's optional. Okay, there we go. X squared plus 7x plus 10. Holy guacamole. 10. Okay. We're just going to factor this, right? We set him not equal to 0. Okay. Now, factors of 10, same sign that are going to add to give us 7. Since this sign, this means they both get pluses, right? So what is that going to be? You got it. 5 and 2. X squared, turn it around, that tells us there's 2 x's. Bam. Well, maybe. Good grief. Okay. X. Plus 5. This is usually a pretty quick process, but not on this tablet. And both of these cannot equal. And here we go. It's going to get really big. Can't equal 0. All right, we're just going to end it there because y'all know how to go from there, right? Just move it over. Set both of them not equal to 0. Move it over. Put it on a number line. Write it in interval notation. Have a great day. I promise to get better on this tablet. Yes, I will. Okay. Enjoy your day.